March 17, 1943. North Atlantic, 400 miles south of Iceland. Convoy HX-229 pushes through 15-foot swells, 41 merchant ships hauling 140,000 tons of vital cargo for Britain. Amidst the chaos of the rolling seas, 28-year-old ship's cook Thomas "Tommy" Lawson washes dishes below deck on the SS William Eustace, the ship groaning with each violent roll. His hands move mechanically, scrubbing the plates, the ship's motion almost like a cruel rhythm of war. A ship's cook, not the one you'd expect to change the course of history, but Tommy had something in his heart that no one could have anticipated. Above him on the bridge, Captain James Bannerman stands, scanning the horizon with his binoculars, feeling the weight of the situation. He knows what's coming. The U-boats are out there, waiting. Beneath the cold, dark waves, 600 yards off the convoy's port side, Captain Lieutenant Helm Mansack sits in the control room of U-758. His hydrophone operator presses his headphones tightly to his ears, whispering to him. Contact bearing 280, multiple screws, heavy machinery noise. The operator's voice trembles slightly with excitement as the U-boat silently positions itself to strike. Mansack's lips curl into a smile. The German wolf pack had its target, but neither Bannerman nor Mansack knows what Tommy Lawson has just discovered about the way the Liberty ships sound underwater. A simple observation, made by a man with no more than a basic education, would change the entire Battle of the Atlantic. But for now, all they know is the impending storm of destruction. Over the next 6 days, 22 merchant ships from Convoys HX-229 and SC-122 would sink into the cold, unforgiving depths of the North Atlantic, their cargo and souls lost to the abyss. 300 merchant seamen would be sent to the sea's unforgiving embrace. It would become the worst convoy disaster since 1942. German Admiral Karl Dönitz, commander of the U-boat fleet, would later describe the event as the greatest convoy battle of all time. The losses were staggering. March 1943 was a dark month. U-boats sank 567,000 tons of Allied shipping, more than in any previous month of the war. Britain was on the brink, its food supplies dwindling to just 3 months. Prime Minister Winston Churchill would later confess, "The only thing that truly frightened me during the war was the U-boat peril." The Germans had perfected the art of listening. German hydrophones could detect convoy propeller noise from 80 nautical miles away. The sound of individual merchant ships was clear and betraying, their distinctive acoustic signatures acting like a beacon for the waiting U-boats. As the convoys plodded forward, Allied escort vessels fought with everything they had: zigzagging patterns, radio silence, ASDIC sweeps. But nothing worked. The convoy's noise was too loud. The ocean carried sound for miles, and the U-boats, lurking silently 400 feet below the surface, listened carefully, waiting for the right moment to strike. All the while, the solution the Allies so desperately needed wouldn't come from a naval engineer or an acoustic scientist, but from an unlikely source: a ship's cook. Tommy Lawson, a man without any formal education, had begun to notice something peculiar about the way the Liberty ships sounded underwater. Something that no expert had considered, and something that would change everything. The Western Approaches Command in Liverpool had been struggling against the U-boat menace for over 3 years. The Royal Navy had deployed everything they could, from sonar devices to radar. Yet despite their best efforts, the U-boats kept coming, their silent, deadly attacks impossible to predict. In 1941, the Royal Navy installed ASDIC sonar on all escort vessels, which could detect submerged U-boats at 2,500 yards, but only if the submarine was directly ahead. U-boats quickly adapted, attacking from angles where ASDIC was ineffective. Even more devastating, U-boats could attack at night while surfaced, using no sonar, making their presence almost impossible to detect. In 1942, scientists at the Admiralty Research Laboratory developed a new tool, high-frequency direction finding, called HFDUF. It was a brilliant innovation, able to track U-boat radio transmissions. But it wasn't enough. Once a wolf pack made contact with a convoy, they would stop transmitting. They would just listen. The convoys, on the other hand, could not stop making noise. Every turn of the propellers, every engine, every movement of the hull betrayed their positions. No matter how hard the Allies tried, the U-boats would always hear them coming. The situation grew desperate. British naval engineers were tasked with finding a solution, but nothing worked. They even tried adding sound dampening mounts to machinery on the ships. But the cost of such modifications was astronomical, and the time it took to retrofit a ship would cripple the convoy system. Others suggested coating the ship's hull with rubber to absorb sound, but that idea failed miserably, creating more drag and reducing speed. A Canadian engineer proposed redesigning propellers with swept-back blades to reduce cavitation, but again, it was not feasible. By early 1943, the Allies had accepted a grim reality. There was no technological solution to the problem of convoy acoustic signatures. Merchant ships would continue to announce their position to every U-boat within hearing range. The only hope was to add more escorts, more air cover, and pray that enough ships would survive to keep Britain in the war. But as the clock ticked down, Tommy Lawson, the unassuming ship's cook, had a moment of insight. A simple observation during his off-duty hours, while sitting in the ship's engine room, began to evolve into something more. Tommy had noticed that the sounds of the Liberty ships were not uniform. Something about the way they sounded underwater was different, and it troubled him. What started as a fleeting thought turned into an obsession. A single question. Why was it that, despite the convoy's size and the noise they made, some ships simply couldn't be heard? As Lawson spent more time in the engine room, his ears became attuned to the underwater sounds, the subtle differences between each ship. He realized that the sound signature of his ship, the William Eustace, was unlike the others. It was quieter, almost silent when submerged. And Tommy Lawson had the audacity to believe that he could fix the problem. While others argued over the limits of technology and the state of the war, Tommy's humble, untrained insight would lead to the first steps in a revolutionary shift. In a time when the highest minds in the military and industry were stumped, a simple ship's cook was about to prove them wrong, using his instincts and his experience in the galley to change the course of the Battle of the Atlantic. This was a moment when genius didn't come from laboratories or factories. It came from the heart of the sea, in the belly of a ship where a cook could hear what no one else could. The fate of the convoy and of an entire war would depend on what this man had discovered and what the Allies were about to do with it. The story of how Tommy Lawson's simple idea would alter the course of the war is one of the greatest untold victories of the Second World War. And it all started with a cook, a ship's engine room, and a question. The North Atlantic was a treacherous place on March 24, 1943. Convoy HX-229, made up of 63 ships in 9 columns, pushed through the harsh, towering swells. The convoy's purpose was simple but vital: carry 140,000 tons of essential cargo to Britain. Amidst the relentless waves, deep below the deck of the SS William Eustace, 28-year-old ship's cook Thomas Lawson worked quietly, washing dishes, his hands moving mechanically, each scrape of the sponge echoing against the ship's groaning metal hull. Outside, the ship pitched violently, rolling in time with the ocean's cruel rhythm, but inside, in the ship's heart, a different kind of battle was beginning to brew, one that would change the course of the entire war. Up on the bridge, Captain James Bannerman stood, his eyes fixed on the horizon through his binoculars. His lips were tight with concern. His brow furrowed as he scanned the waters for any sign of danger. The U-boats were out there, lurking like silent predators, waiting to strike. Beneath the waves, some 600 yards off the port side of the convoy, Capitan Lieutenant Helm Mansack of U-758 sat in the control room, the hum of his U-boat almost peaceful amidst the chaos. His hydrophone operator pressed his headphones tightly to his ears, whispering urgently, Contact bearing 280. Multiple screws. Heavy machinery noise. The operator's voice trembled as he confirmed the sound of the convoy. It was there, all right. Lurking. Detectable. The U-boats were preparing to strike. However, what neither Captain Bannerman nor Captain Mansack knew was that below decks, in the depths of the William Eustace, Tommy Lawson had noticed something strange about the way the Liberty ship sounded underwater. The sound was different. There was something unusual, almost faint. What Tommy didn't know yet was that his observation would soon become the key to shifting the tide of the Battle of the Atlantic, a battle that seemed, at the time, lost. As the convoy steamed on, over the course of the next 6 days, 22 merchant ships from HX 2229 and SC 122 would sink beneath the waves of the North Atlantic, their men and cargo lost to the ocean's depths. Some 300 men would perish. It was the worst convoy disaster since 1942. Germany's U-boat fleet, under Admiral Karl Dönitz, had delivered a crushing blow to the Allies. For the German Navy, it was the pinnacle of their wolf-pack tactics. But the numbers of this tragic engagement would tell a far greater story, one that would soon start to unfold in ways no one could have predicted. In March of 1943, U-boats sank 567,000 tons of Allied shipping, more than any other month in the war. It was a staggering loss. The numbers painted a bleak picture for Britain. The country had only 3 months' worth of food supplies left. The Prime Minister, Winston Churchill, would later write that the only thing that truly frightened him during the war was the threat of the U-boats. The Germans had mastered the art of silent stalking, hydrophone technology that could detect convoy propeller noise from over 80 miles away. The cavitating propellers, the hum of engines, the reverberations of hulls, they were like beacons, drawing the U-boats closer, closer, and closer. In those dark, stormy days of early 1943, the Allies had tried everything. Zigzagging patterns, radio silence, Aztec sweeps, every tactic they could think of. But it was all for naught. The convoys were simply too loud. The ocean itself betrayed them, carrying every sound for miles. And in the deep, below the waves, the U-boats sat in silence, waiting for their prey to draw near. Yet, as fate would have it, the solution that would finally break the U-boat's stranglehold over the Atlantic wouldn't come from a naval engineer or an acoustic expert. It would come from an unlikely source. It would come from Tommy Lawson, the cook on the William Eustace. You see, Lawson wasn't trained in acoustics, nor was he an engineer. He had no fancy degrees, no high-ranking positions. He was a simple man, born in South Boston in 1915, dropping out of school at the age of 14 to help his family through the Great Depression. Before the war, he had worked as a line cook in a diner, later becoming a galley hand on coastal freighters. When war broke out, he joined the U.S. Merchant Marine at 26, not because he yearned for heroism, but because it paid better than his job back in Boston. $125 a month, 3 times what he earned working at the diner. Yet Tommy Lawson's quiet life would change forever. As the William Eustace made its way through convoy SC-18 in February of 1943, something struck him, something he couldn't shake. He began to notice oddities in the sounds of the ship's engines when submerged. It wasn't like the other ships. There was something different. Something that felt almost imperceptible. But it was there, hidden in the noise. It haunted him in his off-duty hours as he worked in the galley. And when he had the time, he began to listen closely to the hums and groans of the ship's machinery. The other crew members laughed at him, called him mad. "Tommy's gonna get himself killed down there," they'd say. But Tommy couldn't let go of what he had heard. During one of the convoy's routine drills, a torpedo struck a ship 2 columns over. Lawson heard the explosion, of course, but it wasn't the explosion that caught his attention. It was the aftermath, the strange, hollow, booming sound that followed. Then all was silent, the water flooded the hull, and with it, all the vibrations of the machinery ceased. Lawson, crouched by the main steam line, grabbed the ship's engineer, a gruff Scotsman named Donald MacLeod, and said, "The ship, it stopped making noise." MacLeod stared at him, confused. "Of course it stopped," he snapped. "It's full of water." But Lawson, still gripping MacLeod's arm, struggled to explain. "No. When the water floods the hull, it stops the machinery's vibrations. The U-boats can't hear it anymore." It was then that an idea, simple yet bold, began to form in Tommy's mind. He wasn't an engineer, but something about what he had just observed sparked a possibility. What if they could intentionally flood parts of the ship? Not enough to sink it, of course, but just enough to silence the machinery's noise? MacLeod, naturally, scoffed at the idea. "That's the stupidest thing I've ever heard. Get back to your galley." But Lawson couldn't let it go. Over the next 2 weeks, Lawson sketched out the idea in a notebook. Diagrams of water-filled chambers around the propeller shaft, ballast tanks designed to dampen the vibrations, controlled flooding systems that would hush the ship's mechanical noise. He showed them to MacLeod, to the first mate, even to Captain Bannerman, but all of them dismissed him. "Leave the engineering to the engineers," Bannerman had said, shaking his head. Despite their dismissals, Lawson couldn't let the idea go. It was all he could think about. And so, when the William Eustace docked in Liverpool for a short 48-hour shore leave, Lawson did something entirely unauthorized, something that could very well end his career. With no official military credentials, he walked straight into the Western Approaches Command headquarters, asking to speak to an admiral about U-boat detection. He was immediately intercepted by 2 Royal Navy Shore Patrol officers and escorted out of the building. But just as the officers were about to throw him out, a voice stopped them cold. "Wait." It was Commander Peter Gretton, a 29-year-old Royal Navy officer, battle-hardened after losing 13 merchant ships to U-boat attacks. His fatigue was palpable, his desperation evident. He was willing to entertain any idea that might give them an edge against the U-boats. Lawson, without skipping a beat, explained what he had noticed: the ship going silent after flooding. The idea of water dampening the machinery's vibrations. Gretton listened in silence, arms crossed. When Lawson was done, Gretton said, "That's the most ridiculous thing I've heard all month." But then, something shifted in him. "Wait, say that again? Acoustic insulation?" He was intrigued, and suddenly, the cook's idea didn't seem so ridiculous anymore. What followed was an act of desperation that would change everything. A small-scale, unauthorized test of Lawson's theory was conducted on the corvette HMS Sunflower, currently in dry dock. 3 days of jury-rigging a crude prototype followed. Oil drums were welded around the ship's propeller shaft housing, filled with seawater, and sandbags were placed to simulate ballast. It was an ugly, unorthodox setup. But it worked. And it worked better than anyone could have imagined. The first test of the Sunflower's modified design yielded unexpected results. The ship's acoustic signature had been reduced by an astonishing 97%. The U-boats couldn't hear it. Tommy Lawson, the humble cook, had just changed the rules of the Battle of the Atlantic. And the impact would be felt not only in the waters of the North Atlantic, but also deep within the corridors of Naval Command. It was a victory forged not in the minds of naval engineers, but in the quiet moments of a cook's reflection. The sound of the ocean crashing against the William Eustace's hull echoed through the engine room as Tommy Lawson, the ship's cook, continued to ponder his idea. The storm outside raged, but inside, there was a quiet intensity. Lawson crouched near the main steam line, watching the machinery tremble in sync with the ship's rhythm. He could feel the vibrations in his bones, the steady hum of the engines, the deep groan of the hull as it battled the Atlantic's merciless swells. It was the sound of war, a symphony of steel, steam, and noise. But it was also the sound of something more, a realization that had begun to dawn on him. Through the chaos of the engine room, a voice shouted, "Get back to your galley, cook. This is no place for you." It was the ship's engineer, a burly Scotsman named Donald MacLeod, who had little time or patience for ideas beyond his own mechanical world. A torpedo had just struck a ship 2 columns over, and the William Eustace shuddered violently under the strain of the convoy's peril. The alarm was blaring, but Lawson's mind was elsewhere, racing. The hull groaned again. But this time, Lawson heard something different. After the explosion, the strange, hollow booming sound, followed by silence. It was the silence that caught his attention. The water rushing into the damaged ship's hull seemed to drown out all sound. The machinery stopped. The U-boat lurking beneath the waves could no longer hear the ship's engines. Lawson turned to MacLeod, gripping his arm tightly. "The ship! It stopped making noise," Lawson said, his voice tight with urgency. MacLeod stared at him, confused. "Of course it stopped. It's full of water," he said, as if the answer was obvious. "No," Lawson insisted. "I mean it stopped making noise. The machinery's vibration is gone. The U-boats can't hear it anymore." MacLeod stared, his brow furrowing. "You're mad," he muttered, shaking his head. "That's the stupidest thing I've ever heard. Get back to your galley." But Lawson couldn't shake the thought. His mind, as restless as the ocean outside, spun with possibilities. What if they could flood parts of the ship intentionally? Not enough to sink her, of course, but just enough to mute the hum of the machinery, to hide the ship from the deadly sonar of the U-boats. He couldn't let the idea go, no matter how ridiculous it sounded. Over the next 2 weeks, Lawson spent his off hours sketching his ideas in a small notebook. Water-filled chambers, ballast tanks against engine mounts, controlled flooding systems, all carefully drawn out, simple yet effective in theory. He shared his designs with MacLeod, who dismissed him, laughing it off. He showed them to the first mate, who laughed even harder. And then, with hesitant hope, he took his plans to Captain Bannerman. The captain listened, nodded, and sighed. "Son, I appreciate your initiative," Bannerman said with a half-smile. "But leave the engineering to the engineers." No one took Tommy Lawson seriously. The cook, the outsider, the man who wasn't supposed to know anything about engines or machinery. But Lawson's mind was relentless. The idea wouldn't leave him. Every time the ship groaned or shuddered in the water, the sound haunted him. And then, as the William Eustace docked in Liverpool on March 24, 1943, for a short 48-hour shore leave, Lawson made a decision that would alter the course of the war. He was going to take his idea directly to the heart of the Royal Navy. He walked into the Western Approaches Command headquarters, asking to speak to an admiral about the U-boat problem. The guards at the entrance stopped him, of course. "You can't be here, mate," one of them said, grabbing his arm. "This is a restricted military facility." But Lawson was determined. "I need to talk to someone about convoy noise," he insisted. "I've got an idea. Please, I need to tell someone." The guards, unamused, started to escort him out of the building when, across the room, a voice called out, "Wait." It was Commander Peter Gretton, a 29-year-old Royal Navy officer. Gretton was battle-worn, having just returned from convoy ONS-5, where he had lost 13 merchant ships to the relentless U-boats. He was exhausted, furious, and desperate for anything that could turn the tide in the Allies' favor. Gretton was willing to listen, even to a cook with no credentials. "What did you say about convoy noise?" he asked, his voice tight with urgency. Lawson, taken aback by the attention, quickly explained what he had noticed, how the sinking ship had gone silent, how the water flooding the hull had silenced the machinery vibrations, masking the ship from the U-boats. Gretton listened, his arms crossed, his face unreadable. When Lawson finished, the commander shook his head. "That's the most ridiculous thing I've heard all month." But something in the way Lawson spoke, something in the raw honesty of his words, made Gretton pause. "Wait. Say that again?" Gretton's voice softened. "Acoustic insulation?" Lawson explained further. "Water absorbs vibration better than air, better than steel. If we position water-filled chambers around the propeller shafts and engine mounts, we can create barriers to prevent sound from traveling through the ship's hull into the ocean." The commander's expression slowly changed. He had heard enough about engineering principles to know that this was no small thing. "Come with me," he said. And just like that, the cook found himself at the heart of a naval experiment that could change everything. The next day, March 25, 1943, Lawson was brought to the HMS Sunflower, a corvette currently in dry dock in Liverpool for repairs. The ship was a small, unremarkable vessel by most standards, but it was about to become the site of one of the most important experiments of the war. Gretton, Lawson, and Lieutenant James Whitby, the ship's engineer, set to work. They welded empty oil drums around the propeller shaft housing and filled them with seawater. Sandbags were placed to simulate the weight of the water against the engine mounts. It was crude, untested, and unauthorized, but it was all they had. 3 days later, on March 28, 1943, they conducted their first test. The Sunflower motored slowly out into the Mersey River. A submarine HMS Trespasser submerged 500 yards away with its hydrophones active. Lawson stood on the deck, holding his breath. He watched as the submarine captain surfaced and signaled them. "Heard you clear as day," the captain said, shaking his head. "Engine noise, propeller cavitation, same as always." Failure. Lawson's heart sank, but then his eyes widened in realization. The water-filled drums had drained through the seams while the ship was in dry dock. "We need to seal them," he said. "We need to make them watertight." Gretton, his hair a mess from running his hands through it in frustration, looked at Lawson with a mixture of disbelief and hope. "If the Admiral finds out about this," he trailed off. "If the Admiral finds out U-boat are sinking 20 ships a week because we're too proud to test a cook's idea," Lawson responded quietly, "we lose the war." Gretton stared at him for a long moment before nodding. "3 more days," he said. "Then this experiment ends." They worked tirelessly for the next 3 days, sealing the chambers, perfecting the water-filled rubber bladders, creating what naval engineers would later call liquid acoustic dampening. April 2, 1943. The second test. This time, the Sunflower motored at full speed. The Trespasser submerged 1,000 yards away. Minutes passed in complete silence, and then the message came. "We lost you at 400 yards." The submarine captain was astonished. "Whatever you did to that ship, it works." The impact of Lawson's idea was now undeniable. The modified ship's acoustic signature had been reduced by 97%, from 12 miles to just 400 yards. The U-boats couldn't hear it. Commander Gretton knew they were on the verge of something monumental. He immediately requested an emergency meeting with Rear Admiral Max Horton, the commander-in-chief of Western Approaches. With Lawson in tow, Gretton presented the test results. The room erupted in disbelief. Dr. Harold Burris, a naval architect who had earlier dismissed the concept, couldn't believe his ears. "A cook," he said incredulously. "A cook has done what our best minds couldn't?" But Gretton stood firm. "It works," he said. "We tested it. We can't ignore this. The U-boats have been hearing us from miles away for too long. We can't wait any longer." Admiral Horton, a man with decades of naval experience, paused for a long time. He looked at Lawson, his gaze piercing. "Explain it to me simply," he said. Tommy Lawson, just 28 years old, stood there, surrounded by the most powerful naval commanders in Britain, knowing the weight of the moment. He cleared his throat. "Ship machinery creates vibration. The vibration travels through the hull and into the water. Water absorbs vibration better than air or steel. By positioning water-filled chambers and controlling the water distribution, we can silence the noise." The admiral, his brow furrowed, nodded slowly. "It sounds insane, but it works." And that was the moment everything changed. The result of Tommy Lawson's simple idea was nothing short of revolutionary. By May 1943, the modified ships with his acoustic dampening system were ready to prove their worth. It wasn't just about the technology, it was about the people who had risked everything for a chance at victory. In total, the system cost a mere $20,000 per vessel, a fraction of the price of building a new ship. And though the battle for the Atlantic was far from over, the tides had already begun to turn. In just 8 months between May and December 1943, the Allies had lost 329 merchant vessels, down from the staggering 729 ships that had been sunk in the previous months. It was a drop of nearly half. Meanwhile, the U-boats, once the hunters, had become the hunted. Over this period, German submarines lost a total of 237 vessels, a staggering figure that signaled the beginning of the end for the U-boat threat. The numbers spoke volumes. 4,200 merchant seamen, lives that would have been lost in the brutal sinkings, were saved by the simple modification of a few ships. The fog of war, thick with doubt and uncertainty, was beginning to lift. The battle for control of the Atlantic hadn't been won yet. It would rage on until 1945, until the final months of the war. But now, the Allies were holding the upper hand. And this shift in momentum could be traced back to one man, Tommy Lawson, a cook with no formal engineering training, who had seen what others could not. In the post-war years, as the world began to piece itself back together, the full impact of Lawson's idea came to light. In 1946, Admiral Sir Max Horton, who had been instrumental in the success of the British naval forces during the war, reflected on the innovations that had shaped the victory in the Atlantic. Among them, radar, Huff Duff, Lee lights, and escort carriers all played pivotal roles. Yet, in his memoirs, Horton wrote that none were as simple or as effective as Lawson's acoustic dampening system. In his quiet, reflective way, Lawson had solved a problem that had baffled the best minds in the Royal Navy. Tommy Lawson never fired a shot in anger. He never commanded a ship, never gave orders to a crew. But as Commander Peter Gretton would later write in his 1964 book, Convoy Escort Commander, Lawson saved more lives than any captain in the Royal Navy. His genius, as Gretton described it, was seeing what everyone else had missed. It wasn't more technology that was needed, but a better understanding of the very thing that threatened them: the ocean itself. Lawson's idea wasn't about creating more sophisticated equipment, but about working with the environment to turn the ocean's own power against the enemy. From April 1943 to May 1945, a total of 27 Allied merchant ships received the acoustic dampening modifications. Even more impressively, 164 Royal Navy escort vessels were similarly retrofitted. The total amount of steel used for these modifications was 51,000 tons, less than half the amount that would have been required to build 7 Liberty ships. The total cost of the modifications was $6.2 million, an amount that would be the equivalent of $400 million in 2024. This modest invention would go on to have far-reaching effects beyond World War II. The system became standard equipment on all U.S. Navy surface vessels after the war, and it eventually evolved into the Prairie Masker Noise Reduction System, which is still used on American warships to this day. The basic principle of Lawson's design, using water-filled chambers to absorb the sound of machinery, remains the foundation of this technology. Modern systems now use compressed air bubbles instead of static water chambers, but the essence of the invention remains unchanged. In June 1945, after the war had ended, Lawson was awarded the British Empire Medal in a quiet ceremony in London. Despite the recognition, Lawson refused interviews, declined publicity, and wanted nothing more than to fade back into the background. He later turned down a request for an interview from the New York Times in 1947, humbly stating, "I just noticed something and mentioned it. Other people did the real work." Lawson returned to Boston after the war and opened a small diner in Dorchester. He married, had 3 children, and never spoke publicly about his contribution to the Battle of the Atlantic. It wasn't until 1978, when a British naval historian tracked him down for a book about convoy innovations, that Lawson's wife learned the full story. Lawson passed away in 1991 at the age of 76. His obituary in the Boston Globe described him simply as a retired restaurant owner and merchant marine veteran. There was no mention of the acoustic dampening system, no mention of the 4,200 lives saved, and no mention of the fact that a high school dropout with a notebook had forever changed naval warfare. At his funeral, 3 elderly British naval officers attended, men who had served on convoy escorts in 1943 and had survived because the U-boats could no longer hear their ships approaching. One of them placed a note in Lawson's casket. It read, "Because of you, we came home." In 2011, the U.S. Naval Academy included Tommy Lawson's story in its leadership curriculum with a simple yet profound lesson. Innovation doesn't require credentials. It requires observation, courage, and the willingness to challenge expert consensus. Lawson succeeded not because he was trained in acoustics, but because he paid attention when no one else did. He noticed what everyone else missed and dared to speak up. The most dangerous phrase in warfare, as he showed, isn't, "That's impossible." It's, "We've always done it this way." Today, every surface warship in the U.S. Navy operates with the Prairie Masker acoustic reduction systems, descendants of the water-filled chambers a humble cook sketched in a notebook 80 years ago. Sometimes, the difference between defeat and victory is not a matter of more technology or more firepower. It's about one person noticing what everyone else has overlooked and having the courage to speak up. And it was Tommy Lawson, who, without the credentials, without the title, changed the course of naval history, proving that sometimes the simplest ideas are the ones that make the biggest difference.